Today we're going to go over two more ways to prove triangle congruence. So I'm going to remind you here first, before we start, of our proving triangles congruent reference sheet. So far we've done side, side, side. We've done side, angle, side. So we're going to introduce the next two today. So angle, side, angle, and angle, angle, side. So just a quick comparison. This is really good to look at them side by side so you can see the difference. So the first one, we have all three sides. We practiced with that. The second one, we have a side, angle, side, where the angle is in between the two sides. So today we're going to look at angle, side, angle. So kind of the opposite, where the side is in between the two angles. And then we'll look at angle, angle, side. And remember, of all of these, the only one that's not included is, so this is angle, angle, side. It's not angle, side, side. So we don't use that one for many reasons. Okay, but it doesn't work mathematically. So let's take a look at angle, side, angle. So that's what we're going to start with here, and then we'll look at the next one. So much like the other ones, we're going to say if two angles in the included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So, for example, in this diagram here, we would say if angle A is congruent to angle D, so A and D, if those are congruent, and then you have the side here, so if side AB is congruent to side DE. And then also you have this angle. So if angle B is congruent to angle E, then we can say that triangle ABC is congruent to triangle DEF. Okay, so take a look at that. So that's our statement. That's our kind of theorem here, where we can say if you have an angle, a side, and an angle, then we can prove that the triangles are congruent. So we're going to do our proof. So we're going to be using angle, side, angle. Now included, remember, means the side between the angles. So you have to have that side right in between the angles. So our first couple proofs will look at the statements that are already there for us. We just have to provide the reasons, and then we'll go all on our own and have to make the statements and the reasons. And this whole time still, with my doing my proofs, I'm going to be referencing my reference sheet so that I know the reasons that I'm going to use. So this is super important. This is, your answer bank. All of the possible answers are on this paper. So let's take a look at our first problem. So it says, given that SQ bisects angle RQT and angle RST. So these two angles over here are being bisected by SQ, meaning it's cutting those angles in half, okay? So this is going to kind of give us our information right here, where we don't have to figure it out ourselves, but let's go through and say the reasons for these statements. So SQ bisects, how do we know that? That was given to us. So that was actually the only thing that was given to us. So now let's look at this next one. Angle RQS, it says, is congruent to angle TQS. I'm going to label that here. So RQS is congruent to SQT right here, or TQS, either way. So how do we know that? That is the definition of angle bisect. Okay, so that's the definition of angle bisector. And let's say you didn't know that and you couldn't think of that on your own. If you look back at your reference sheet, reasons that angles are congruent, we have right there at the bottom, definition of angle bisector. Okay, and your first clue is, we have bisects right here in the given part, so we're most likely going to be using this reason. So our next one, angle RSQ, so this angle here, is congruent to I'm going to use a double arc, so RSQ is congruent to TSQ. So double arc. So these two are congruent for the same reason that these two are congruent. So that would be what? Definition of angle bisect. I'm just kind of abbreviating. You can put bisect or just bisect. So then we have that angle. So notice what we're actually trying to do here. We're doing an ASA proof. So we're doing an angle, side angle proof. So we actually want this side right here, because then you have angle, side, angle, angle, side, angle. So they're sharing that side. So we know that QS is congruent to QS. So remember back to our other proofs, how do we know that that is congruent, QS to QS? The reflexive property. So same as before. So this should start to seem a little familiar. The reflexive property. So now that we have an angle, a side, and an angle. So this is ASA. This is an angle, side, angle proof, and we're done. So using the same exact type of steps as the other proofs that we've done, it's just we're using a different method. So we're using angle, side, angle as opposed to side, side, side. So let's take a look at another one. And this one involves parallel lines. So sometimes this can be a little bit tricky with identifying our angles and everything like that. So let's go through and state our reasons and also label our diagram here. So it tells me that JK is parallel to LM. So JK, this side here, is parallel to LM. And JL is parallel to KM. So basically these two sides are parallel. So what you have are pairs of parallel lines, and then this KL is kind of a transversal. So how did I know those were parallel? It was given to me. Given. And so now this one, that's really our only given thing. So we have to now establish what kind of angles these are. So it actually tells me here that J, so let's look here, JKL, JKL, so we're talking about this angle here, is congruent to MLK. Okay, so let's see, do you remember why that would be the case? Why are those two angles congruent? How did they know that? So this came up in a proof yesterday, so maybe you remember it, maybe you don't. Let's take a look at our options here for when we're talking about why angles are congruent. So remember, my first clue, we're using parallel lines, so it's got to be one of these, okay? And what you should see is that these types of angles, when they're on the opposite side, like that of this line, they're on the opposite side, and then they're inside the parallel lines, that's an alternate interior angle. So we're going to say that these are alternate interior angles. All right, and remember, a lot of problems do involve alternate interior angles. Just, FYI, of course, not always, but a lot of problems do, because we end up with these, in these angles that are inside the parallel lines, and they're usually cut by some sort of transversal. So now let's do the next one. So it says angle JLK. So JLK. So now this one here is congruent to angle MKL. So MKL. Okay, so why do you think those two are congruent? What would be our reason? Remember the options that we have. So these are congruent also because of alternate interior angles. So they're just another pair of alternate interior angles. So, it's totally fine that we're using the same thing twice. That doesn't matter. We can use it as many times as we're dealing with those types of angles. So we have two angles now, okay? Angle, 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 angle. So which side would be in between those two angles? KL is. So KL is congruent to KL. That's this segment right here. So it's congruent to itself. What property says that? The reflexive property. Okay, so we kind of got to the same point as we did in the last one, just took a different route. So what did we use? We used angle, side angle, and you can see we've got an angle, a side, and an angle, side, angle. Okay, so let's take a look at this last proof for angle, side, angle. So we're all on our own on this proof. There's no statements for us. We have to come up with everything. So let's see if we can do this. So first, let's label what they gave to us in our diagram. So we're going to have to be thinking a little bit more on this one with how we want to get to that angle, side angle, or relationship. So it says that angle BAC is congruent to angle DEC. So BAC, so we're talking about this angle right there. And then it also says that C is the midpoint of AE. Oh, whoops, I didn't mark the other one. Sorry. So DEC. So DEC right there. And then the next thing, so C is the midpoint, so it's halfway of AE. It cuts it in half, which then means that this is congruent. Okay, so now I'm going to write down my given stuff that I just labeled on the figure. So the first thing, angle BAC is congruent to angle DEC. That's given to me. So always nice and easy to write in my given stuff. Then C is the midpoint of AE. That was given to me. So then I also want to go ahead and state what I just showed on my figure. So I just showed that AC was congruent to EC. So since I did that, I want to also state that in my column here. So AC is congruent to EC. And how do I know that? The definition of midpoint. Okay, so now this is where kind of on my own, I actually need to think a little bit. So you know that we are doing angle, side angle proofs. So I have an angle, I have a side. This means I need this angle. I need to show that these two angles are congruent to each other because I'm looking for that angle, side angle relationship. So I'm looking for ASA, angle, side, angle. If I somehow proved that D and B were congruent, that's great. But that doesn't have an angle side angle relationship. It needs to be all right next to each other, and that side has to be in between those two angles. If I knew that this one, D and B, were congruent, then I would need this side right here. So the side has to be in between the two angles. So I need to somehow prove that this angle right here is congruent to this angle right here. Okay, so I'm saying that those angles are congruent. Okay, so I'm going to write that down. So, and then we'll talk about the reason that I know that those angles are congruent. So maybe you know the reason, maybe you don't. So I'm going to say angle BCA, angle BCA is congruent to angle DCE. Okay, so let's say, how did I know that? Let's go back to my reasons that angles are congruent and see what it is. Okay, so it wasn't given to me. I'm not dealing with parallel lines, not dealing with an angle bisector. They're vertical angles. Okay, so they're across from each other. So maybe you remembered that. That's great. So these are vertical angles. And now, so I've got an angle, I've got a side and an angle, and they're in that order where the side is in between those angles. So I can go ahead and write my congruency statement and say that triangle ABC is congruent to triangle EDC, and that is by angle, side angle.